Welcome back to the third lecture of this week. So we have talked about different approaches of summarization. This lecture we are talking about evaluation. So how do you evaluate the summary that you have obtained using your system? So what do I mean by evaluation? So you run your summarization algorithm on your document set, and then you are getting some set of sentences. So as such, assuming that you are running as extractive summarization, you will get a set of sentences as an output. You can also run different sort of abstractive summarization or whatever, and you will get different sort of sentences as your output. Now, how do I find out how good my summary is? So as such, if we talk about, so we will see what should be in criteria of evaluating a summary. So we say, okay, if you give it to a human, so human should say, okay, this summary contains a good amount of information from the original article. So that is one criteria can be what is the informational coverage of this summary, and then we can talk about how diverse the sentences are. So you are getting different sort of summary in here. You may talk about readability if you are doing an abstract summarization, and there can be some other criteria depending on what is your task. So are you getting the information that you wanted from this summary? So this you can do by some sort of human evaluation. You can give this summary to some humans and ask them to rate this summary along these points from a scale, say 1 to 5, and it's okay how good this summary is on a scale from 1 to 5 as per the readability, as per the information coverage, as per the diversity, and so on. So, but what we will see is there some method by which you can automatically evaluate how good this summary is with respect to the document, and there are some methods for doing that, and one very popular method is using the Rouge score, and that's what we will see. What is the idea? So your system is generating a summary for this document. Now in Rouge method, you will assume that there are some humans that have created a gold standard summary for this document already. Okay, so this helps in that you can now try out different systems, get the summary, and find out which one does the best with respect to the human. So you have a human summary and you have some system generated summary, and you want to compare these. So and this comparison is done by an approach. It's called the Rouge approach. So what do we have? So we have the system generated summary here, some sentences, and a reference summary that is created by the human. Now in general, it may happen that you want to create multiple summaries for the same document. So the same document might have multiple reference summaries, so 3 reference summaries or 5 reference summaries. Still, you should be able to compare this with the system generated summary. So the approach that is used is called the Rouge evaluation. So recall oriented on a study of for listing evaluation. So this is not so as good as doing a human evaluation, but still it is quite convenient, because for summarization you have a lot of different competitions and benchmark data sets. So what you want to see that different systems, as people propose different algorithms, are they able to improve on the previous approaches or not? And a human evaluation may not be, first of all, feasible for doing for different algorithms, different variations, and if it is there, it may not be very reliable. That do you get the same humans again and again, and even if they are from different volunteers, how much they agree and all. So there can be many other issues with that. So using an automated evaluation avoids all such problem, and you say that okay, for a benchmark data set, so for summarization there are data sets like that are given in document understanding conferences. So they are by the name of DOC. So DOC has multiple data sets, so DOC02, DOC03, and so on. So there, what do you have? You have some documents. So like say there may be roughly 400 documents. For each document, they provide some manual summary. Okay, so this is again by using certain guidelines, they have built the manual summary. So they have done it once for all these 400 documents. So now, once you have your algorithm, you again produce them the summary for these 400 documents. Okay, so this is your human summary, this is your system summary, and then you try to see how close is some system summaries to the manual summaries. And this thing you will do for, so now you can vary your algorithm and see, okay, I will find the how good this algorithm works on this data set, how good the other variation works on this data set, and you can also compare on this benchmark. So that's why this automated evaluation is helpful. Now Rouge is one very popular method for doing this. So let us see what is the basic idea for Rouge. So Rouge again has many different variations. So that is, do you want to find out similarity on only the unigrams, that is single words, how much single words are matching, or bigrams, how many bigrams are matching, or you want to go for longest common subsequence that you are matching, and like that there are many variations. So most popular ones are Rouge 1 and Rouge 2, how many unigrams are matching and how many bigrams are matching between the two. So what is the actual approach for doing that? So suppose I have a document D and an automatic summary X. X is what my algorithm is providing. Now what I will do, I will have n humans produce a set of reference summaries. So like I did in this DOC data set, so there are suppose 3 humans, they produce summary for each of this document. Now I have the automatic summary X. So what I will do, I will find out what percentage of the n-gram from the reference summaries appear in X. So this is like I am finding the recall, how many n-grams from my reference summaries are appearing in the system summary. So this n I can vary from 1, 2 and so on. So if I take n is equal to 1, this is the Rouge 1 measure. If I take n is equal to 2, this is the Rouge 2 measure. So this is the example for using a used to measure, that is you are taking bigrams. So what you are doing, so you are counting, so your numerator is for all some reference summaries, for all the bigrams that occur in the reference summaries, find out how many are matching with the system generated X, how many bigrams are there in the system generated summary X as well. So you are counting that, your numerator. What is denominator? Denominator is for all the reference summaries, for all the bigrams, count how many bigrams are there. So that is you are finding out among all the bigrams that you can find in all the summaries, how many are present in the system summary. And immediately you can see that if a bigram occurs in many of the human generated summaries, it gets a higher weight. So if that bigram occurs in the system generated summary, it will start giving it a high weightage. So this is a very simple approach, but this has shown to correlate a lot with the human judgments, and this is one of the very popular method for evaluation. So this is well accepted method. So let us try to see how this works on a simple example. So suppose I have a document and there are 3 reference summaries provided by 3 humans. So first summary is what is spinach, is a green leafy vegetable grown in the tropics. Second one, what is spinach, is a semi-aquatic tropical plant grown as a vegetable. And third, what is spinach, is a commonly eaten leaf vegetable of Asia. 3 different reference summaries. And now your system produces this summary. What is spinach, is a leafy vegetable commonly eaten in tropical areas of Asia. So what you will do, so you will find out how many bigrams are common in human summary 1 and system summary, plus common bigrams in 2 and summary, plus common bigrams in 3 and summary. That will be your numerator. Denominator will be bigrams in 1 plus bigrams in 2 plus bigrams in 3. So what are the bigrams in 3? So the bigrams will be 1 less than the number of words. So because I can take bigram like what is spinach, spinach is a, and so on. So number of words are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So there are 9 bigrams in third summary. Similarly here 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 10 bigrams, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 10 bigrams. So my denominator here is 29. Now what will be my numerator? So numerator would be how many bigrams are common from here to each of these. So let us see system summary in human 1. What is spinach is common? 1. Spinach is 2. AJ 3. Then that's all. So there are 3 bigrams are common between system summary and human 1. System and human 2. what is spinach 1, spinach is 2, ej 3, and then nothing else, no other bigram occur in both. So plus 3 and system and human 3, what is spinach 1, spinach is 2, ej 3, then commonly eaten 4, then leaf vegetable 5, of Asia 6. So number of common bigrams are, so 3 plus 6 divided by total bigrams 10 plus 10 plus 9. That is the Rouge 2 score. Now this you will compute, so this you have computed for this one document, you will compute it for all the documents in your corpus. So there is a toolkit available for Rouge, you can download that toolkit, set up your system, and then you will give all the documents, it can compute all the scores, Rouge 1, Rouge 2, there is Rouge L, and so on. There are many other scores that you can compute, and it can also tell you the confidence interval and all, and then you can compare different approaches, how much the Rouge scores are different. Now one thing that you must be careful while using the Rouge approach, in general when we are doing it for some benchmark data sets, we have some constraint that I want a summary of length 100. But suppose when you are running your system, some sentences are having, so you are stopping when the length is just above 100. So suppose you are stopping at 105, 107, 108. So if you want to use those summaries also, there is a way in which in the toolkit you can provide this, say that I have the length, I should consider only length up to say 100 of a given system summary. So there is a parameter that you can set in the toolkit that say, okay, I will take only up to 100. The first 100 words will be taken, everything else will be left out. So that is possible. So by the same method summary, you can choose different lengths. You can also say that I want to do stemming. So stemming will help in that words like boy and boys will be starting matching. If boy occurs in reference summary and boys occurs in the system summary, it will not match here, but if you say, okay, I will do stemming, then it will start matching. You can also say that I will remove stop words before computing all this. So that way you are only matching the non-stop words, not like is and a occurring in both. That will not make sense. So there are many other options that you can see in the Rouge toolkit, and they help you in and getting a very good evaluation of your system. So that's what we saw here. So Rouge 2 score, if you compute for this this particular system summary, it will come out to be 0.413, and you can compute Rouge 1 and so on like this by this method. So there are many other methods for evaluation. So one other method is like pyramid evaluation. So where the idea is that you define some sort of semantic content units from your documents, but they have to be manually defined, and that's why it does not become completely automatic. If you have a large corpus, you will have to define on your own some semantic content unit, and then your idea will be whatever summary you are getting, you should have the maximum coverage of those semantic units in a nice. So this is a nice method also, but it is not, it requires you to define these units. And there are other approaches that have seen that, okay, so given the document and the summary, can you find some property among these that can tell you whether this is a good summary or not. But still I would say you can always rely on Rouge 2 if you have a ground truth summary. If you do not have a ground truth summary, one way is you create your own summary, or you do go for some human evaluation if you do not have a lot of documents to evaluate. So that finishes our discussion on summarization. But so there are certain things that we did not discuss. So this is something that we talked in the initial one of the initial slides, that what are the different genres of summarization. So we have focused our whole discussion on single document summarization and generic summarization and extractive summarization. Okay, we were taking the sentences, extracting the sentences. But what about doing a multi-document summarization? So multi-document summarization is not very different from what we have seen here, except that now you are having different documents. So as such, you can apply the same algorithm like lec algorithm, where you take all the sentences in all the documents and apply your algorithm. But there, once you have the summary, you might want to give different weightage to different documents. Suppose you know, okay, one document is more important than another document, you will have more weightage for that sentences from the document. Also, the similarity between sentences in the same document might be given different sort of function and similarity across documents. You might also use how similar two documents are, and so on. So there are many different tricks that you can apply there. But overall, the idea is roughly the same. So it won't be very, very different. Then there is something like a query specific summarization. That is, user has given a query and I want a summary with respect to that query. So one particular approach would be, first you find out what are the sentences that are similar to that query, and then do summarization only on those. So that will reduce your initial set. Or it can be, first you get a larger summary than what you wanted, and then you apply you find out which ones are more closer to the query. Then you retain only that. So first find out the important sentences. From there, retain only those that are closer to the query. And there can be some other methods also. So idea is, and here again you can do a query specific multi-document summarization. So you have a query, you have a whole repository. First find out using some information retrieval method which of the documents are relevant to the query. So this becomes a multi-document set. From there you do your summarization and pick those sentences that are relevant to your query. So this is like you can apply query specific summarization by using the same sort of techniques, but some pre-processing, some post-processing based on the query. And then finally, you have the abstractive summarization. Now abstract is slightly trickier. So because you are now not worried about just picking up the sentences, you are taking the sentences. If some sentences contain similar information, you are trying to fuse them together. So what is in general done is that whenever you want to produce an abstractive summary, you apply the abstractive summary first, get a larger set. So that is, suppose I want a summary of length 100. I want a summary of length 100. So what I will do, I will apply a extractive summarization, get a summary of say length 200. Okay, so twice more than what I needed. Now I apply some abstractive method. In abstractive method, in general, what I do, I'll take. So here I'll take. Suppose I have here 10 sentences, 10 or say 20 sentences. Now I'll find out which sentences are very similar to, or close to each other. So suppose I find, okay, S1, S2 and S3 are similar to each other. So what I will do, I'll take the sentences and try to fuse them together to get a say single sentence. And how this fusion will take place? Okay, I'll say, okay, are there some words that are common here and here, and then some information that is providing and some information that it is providing. So I'll take the common part, take information from here and here. So there are many approaches for doing that. Many of them are based on a word graph. So that is, you construct all the words, take all the words in these sentences, construct a graph, and then you try to follow the path. Okay, these words are connected, these words are connected. In the second sentence also, these words will be connected, but there will be some diversion. Wherever there is diversion, you try to take both of these together by doing some sort of language generation. Okay, so that is like you can connect them by AND or some other different connectives, but whatever is common, you will take it only once. So there are again, so this is again a nice area where a lot of work is happening, that how do you construct the abstractive summarization. But again, the idea is that you first take the extractive one and then create an abstractive from there. And again, here you can use your ILP based method to find out what paths to be taken. Paths can be based on the unigrams, bigrams, or higher length. So with that, I'll say that this finishes our discussion on summarization, and this is a very nice application. A lot of work has been done and is being done right now in this field. There are a lot of different applications. So you can talk about news summarization and scientific article summarization. At the same time, you can talk about summarization from your Twitter streams, core answers, Stack Overflow answers, and so on. So a lot of tweets are there for certain events. You want to summarize those. From a disaster event, you want to summarize those. So that's where you can use your extractive summarization, abstractive summarization to also be able to help people. So in the next lecture we will start a new application topic, that is text classification. Again, that is very important, and we will discuss one very appropriate baseline for that.